Let me share my screen. This is three problem statements. For now, we will focus on the first one. The first one is just like, some paper statement or something. But, what I rephrase this one is, let's assuming that we have data, right? So, see, we have different data available, right? What according to the statement, it says that, basically come up with something which category or which type, right? Which has a lot of recycling happening, or, how we can reduce it. It is very high level. You can think like, you have a lot of data, right? Let's assuming that, let me translate this one to, you have a movie theaters, right? All over the place. Every city has a movie theaters. Now you want to find out where you can get the best ticket out of that, right? How can you do? You can go with like you can categorize first, right? You can able to cluster the each city or each state, assuming that, for example, I'm in the United States, right? United States has a 50 states. 50 states has so many cities, right? Or so many towns, you can say. Now, what you have to do for each state, you can divide, right? You can make it as a cluster state. Each state is a cluster. There you can calculate what it is going on. Now here also same formula, right? Today you have one type of waste, right? Tomorrow you can have a different type of waste will be there. You don't know, right? But you need to classify that. You need to quantify that, like a okay, this is the category, this is what happening, this is a progress happening, right? We can able to figure out that, very one way of thinking is, you can say k-mean clustering. Once you do that, these are the clusters are there. On that cluster, you can able to do regression, right? How is that one, each one is doing, what is the thing. Then you can able to, like, for each cluster, how is the recycling happening. Then if we can return that one, based on that, we can take a call. Like, these are the, for this cluster, this is the waste is happening. For this cluster, this is a waste is happening, right? Like that, we can able to come up with that one, right? That is a one kind of way of thinking, but you can come up with different approaches, but this is one of the easiest way of thinking, right? And then if you have any ideas, open to listen, and then you guys can share each other, and then come up with the solution. Okay, I'm just opening the floor, and then if you guys have any, I mean, like any suggestions or any questions, let me know.
Hi, Vijay.
Yeah, hi.
Sorry, I came in a little bit late. I don't know whether you people have already discussed, but regards to the question that I posted in the channel concerning the labeling of the data, I don't know whether you have spoken to that or you are yet to speak to that.
See, whatever the data we have, right? Based on that, we have to come up with a solution, right? It is not like we can't change the what you call data, right? Data, whatever we have, based on the data, we need to come up with the prediction, right? Let's assuming that there is so much waste is there, right? You can't like you need to, based on the characteristics, right, type and other things, you need to classify, you need to cluster, right? Based on the cluster, you need to do regression. You need to, okay, for this cluster, this is what the waste is happening, right? This is our projection. and then another cluster. This is what the thing. Like that, it very simple way of thinking is k-mean clustering plus some regression model. If you apply it for each cluster, and then you can able to return for each cluster results, and then you can, based on that, we can able to do some kind of a prediction, right? It is manually, okay, this is, we want the highest or lowest, what is returning, which category is returning, something like that. Let's assuming that, right, today we collected some data, tomorrow some other data comes, right? How can you do, right? You can't like do it like it going to be so many types. It is not going to be efficient. We need to make it as a cluster, and then each cluster which is having the what you call user simple linear regression, and then we can able to predict it. Okay.
Okay.
Hey guys, don't ask me to check the code and other things, right? Please work yourself and then do it, right? I'm very busy. If 50 people going to ask me, I don't have time. Okay. Please, you guys work it out, right? Because you guys are developers. You should able to do yourself. Because if I keep looking everybody's code, it is going to be too much. Once you are done everything, okay, finally, if we check in the code GitHub, then we can able to do it. Because back and forth, right? It is not like a one-time checking, okay, then, okay, I'm getting this error, that error. You guys has to Google it and figure out. Okay, because I don't have time that much. Because if everybody asks, right, I don't have bandwidth to help that way. Okay, because we are collaborating, right? Everybody, each one can answer it. Okay, if you guys done everything, create a folder under a task 4, and then check in your file. And then, based on the performance matrix, we will know that, okay, this is good, this is bad, right? Whichever gives the best result, we can consider it. Okay. Any other question?
Yes, please.
Yeah, go ahead.
I was just asking if there is a unified evaluation metric which we can use to evaluate our model.
We can do root square or any. I mean, like you can try.
Okay.
And then different methodology you can use it, but what algorithm you are using, and then you can use accordingly. If it is linear regression, root square is very popular. And then try it out and see how it works. Yeah, because we don't want to do anything difficult for anybody. We want to do very simple and easy solution, because we don't have a lot of data which can able to do lot of things, right? We have like a data for yearly, and then something like that. We can't able to do time series. Time series needed like a sequentially lot of data, then only.
Yes, there is too many years missing in between.
Yeah,
Examines that. Yes.
yeah, exactly. And then if you aggregate everything for like a 2006 to 2021, it is hardly has a 17 or a 20 record. 20 record you can't do machine learning.
Yes.
You need to, yeah, you need a lot of data, like at least 10 years of data daily. I mean, not even like 20 minutes or something, but at least daily data. If we have, we can do time series. For now, I don't think we can do time series. Based on the yearly, and then we apply the algorithm, and then which can able to give progressively what is going to happen, projection, right? It is simple, think like what is the salary in after 1 year, right? Something like that. Recycling also, what will happen after, I don't know, 6 months or after a year or whatever. We can able to project it, right? We can able to come up with some idea. Because now,
understood.
Yeah, simple. We want to make it simple and then make it work. That's our goal. Yeah,
I agree with that.
we don't want to make any complicated. If you go deep learning and all those stuff, that will make very difficult. It is not going to solvable by anybody, because the most
Yes.
of the work can be done with simple algorithms, and then it can solve many things, you know. Yeah, I don't want to say this algorithm or that algorithm. I want you guys to try it out. Another thing is, I strongly recommend you guys to use a pipeline if you are using a supervised learning, so that you don't have to do min-max scaling, and all the things will be very easy for you. You don't have to do any complicated. Let me share and then give little glimpse. I think the simple logic here is, I'll just give one suggestion is, right, when you do pipelining, right, and then you prepare a pickle file, you don't need any kind of other pickle file to one hot encoder or anything like that, in case if you are doing like a min-max scaling or anything like that, right? What you have to do is, in order to do that, just like whatever you are planning to do, simple methodology is, you just, sklearn has a pipeline, you just keep putting the steps, right? First step will be min-max scaling. For example, I'm not suggesting to use this way, I'm just giving a one of the sampling. Okay, then I'm doing another step is one hot encoder, right? Then another thing is a column transformer. Okay, then if it is a numeric value, how you transform. If it is a category value, what you do, right? All the things you can do. For now, here the random forest, right? Random forest, you are up. This algorithm is there. Now, if you look here, the you have two steps, right? One is a pre-processing step. If you look here, the pre-processing step, what I have adjusted transformations are there, right? These transformations, if you look here, what are the features we are doing? This is at the top. What are the column names, right? And then what is the category name? If it is a category, what we are doing? We are doing one hot encoder. If you do simplicity, you don't need any translation or anything. And then you just do the steps, right? Now what happens is, when you something is like when you are testing the real application, then the advantage with this approach is, you don't need to, for example, if the input is like a Vijay, right? Any text, you don't need to do translation automatically with a pipeline. When you save the model at the bottom, it will automatically take care for you, because with the model we are including like a pipelining. When you open this pipeline model, when you are testing something, you're just giving a inputs, your own inputs. There is nothing like you're translating black into some one hot encoder or anything like that. Now it gives the output automatically. Okay, this is a one way of easy way of doing. Okay, I will share this link also if you guys want to take a look or anything. But I just there is XGBoost is one of the popular algorithm. You can use it, right? I'm not telling to use any of these algorithms for our use case. You guys think through what goes well, because you guys has to do little bit EDA and other things. Okay. Okay. Any questions?
Hello, Vijay.
Yeah.
My question is that which dataset we should use? Basically, if you share your screen, yesterday I was just trying the hazardous dataset.
Mm-hmm.
Both the dataset had different shape and size. Okay. So should we focus on only one data set like hazardous and another one, or specifically in this classification task we have specific data set?
No. Whatever we have, use it, that one, because we can't change anything now, right? Because this is too late in the game. Whatever is available for us, right? You can pick one data set if it is good for you, right? Try it out and then see how it works, right? Once it figure out, then adding another data set with the same columns, right? It is not going to be that difficult. Okay. Try one, don't club many things, right? Do one model, one data set or CSV file, right? You want to join, there is another one, it has a very limited thing, and then you want to do everything. Try it out, different combination, right? There is no perfect solution or anything like that, right? Because this is, we are learning the technology, and then, we are applying the real world problem, right? That is our goal, right? Because you go to the Kaggle, right? Many things are there, right? Sample CSV file, you try, you're not going to learn anything. Unless it is a challenging, right? You will learn it, right? Because we are not writing a machine learning algorithm. We are just using the machine learning algorithm, right? In order to do it, most of the work will be on the data side, right? Then you will follow the simple steps, right? Scaling, right? Because you are bringing into the same standard so that it distributed properly, and then algorithm give a proper results, right? Then if you have category variables, machine learning need a numeric values, right? You just to put the how do you want to do, right? 1 hot encoder, right? You just, those things are very standardized. You don't need to do any complication. You just need to know sklearn pipeline, you put together, and then you are done. Okay. Makes sense? Yeah. See, try it out, all the models, right? When you do algorithms, right, there is no perfect solution, right? You try, okay, tree model, right? How it became, how it works, right? If you use what you call XGBoost, how is going to work, right? You can try all the combinations and then see what it works, right? See, we are trying to apply the algorithm what data we have, right? Because there is no perfect solution here, right? Because we, due to the time limitation, we just go with the flow. Okay. Anybody has any questions? If nobody has any questions, then what we'll do is we will connect again, might be today is Thursday. If you guys want one more, tomorrow we can connect noon time. And I live in New York, 12, that time it works, we can connect again. If you have any questions, or if you want Saturday we have a meeting, then we will see if you need it on Sunday or something. I'm flexible, because that way that everybody doubts will clear one shot. Okay.
Hi, Vijay.
Yeah.
So, as you said that time series is not possible with the data that we currently have, right? So, what are we going to do with those data, the data that are related to waste generated and all? What are we going to do with that?
I don't know. Whatever based on the data, we need to apply the algorithm, and then we need to do the thing. Because I'm not involved on the data collection, right? Yeah.
Yeah. So I did some of my initial modeling on